Looking at some of the regional aquifers here across northern Louisiana and East Texas. Again, the Sparta aquifer dominates much of the aquifers here across northern Louisiana, whereas you've got the Carrizo-Wilcox aquifers that are plentiful there across much of East Texas. So taking a kind of a few peeks at some of the aquifers there, don't have much in the way of reporting sites across East Texas, but those that I have been able to find in the western parts of East Texas, in Rush County. This particular well, it's located about 5 miles south of Kilgore in northwest Rush County. And looking over really since last summer and through the fall and wintertime months, of course, temperatures are cooler. We had all the rainfall last fall, and this particular reporting site did recover, and we did see a good 2.5-foot rise in the aquifer levels here at this particular station there in northwest Rush County. Whereas further to the north and west in Smith County, this is up near Tyler State Park in the northeast part of the county. Again, we have seen some response here since the late summer with this particular aquifer rising about 5 feet. So that's good. However, you look at the long-term scales here at both stations, and looking at the last few years here at the Rush County station, and we've seen the levels over a longer period of time beginning to decline. And we're seeing the same result here since the mid-90s here at the Smith County reporting site. Again, definitely not very good. This could be due in part because of increased urbanization around this well site. So more lines are being tied into this particular aquifer here, and so more people are drawing water from it. So again, even with the above normal rainfall that we received last fall, it's still not enough for the aquifer to recover fully to what we've seen here in the past. So, and it looks like this trend will continue as we move in further to the year. We do have a number of well sites here in specifically Caddo Parish, where Shreveport is located here. And this is taken from a collaboration effort between the Red River Watershed Management Institute and the Caddo Parish Groundwater Monitoring Project. And overall, and these are just a number of different sites. The majority of the sites you see here on the bottom are taken from well sites across southern Caddo Parish. Moving further north, these are taken up stations up towards Blanchard, north of the city of Shreveport, in the north central part of the parish. But just doing a comparison since last year, most of the well sites here in Caddo Parish are pretty much right at the same levels as what they were about this time last year. So, but again, the one thing I do want to point out is specifically with the Mayo Road well station here, as well as the Keithville compactor station. Again, these are more subject to more stark fluctuations, especially during the summertime months. These are typically more shallow well sites depicted from this graph here, and so they will respond much more quickly to water use than, say, other well sites further to the north. There is a higher concentration of population, especially here across South Shreveport and across Keithville and the far northern DeSoto Parish that are actually tying in to this particular well here. So, again, it's recovered for the most part for the wintertime months, but again, we will start to see kind of a fall off here as we enter the later spring, especially the summertime months. Hopefully not to the extremes of what we saw here in 2011. These areas here, especially Mayo Road and then Keithville, still remain under rationing of water until these areas are fully recovered, which may not be done tomorrow. So we've basically reviewed what happened here during the fall and wintertime months. So we're going to move forward now, and this is again kind of a review of what we talked about here last time about long-term temperature and precipitation outlooks and how they can be best best forecasted here. So we're kind of leaning towards the ENSO conditions now. We're going out west into the tropical Pacific here, and so again we're going to monitor these areas between 170 and 120 degrees west longitude and areas 5 degrees north and south latitude of the equator. And again, we're looking for El Niño and La Niña conditions to develop, which will ultimately dictate the jet stream patterns and the temperature and precip trends over our area. So as a quick review, El Niño is defined as a warming of sea surface temperatures in the tropical Pacific. It's characterized by a 3-month running mean of sea surface temperatures of 0.5 degrees Celsius above normal. Specifically, the El Niño and La Niña conditions are measured in the 3.4 region, which is depicted by those areas again that I mentioned in the last slide, 5 degrees north and south latitude of the equator and 170 to 120 degrees west longitude. In order to have a distinct El Niño episode, these sea surface temperature conditions again must be met for a period of at least 5 consecutive months. So, in other words, it's a 3-month running mean. So, say January, February, March, April, March, April, May, and so forth for 5 consecutive months. On average, these were taken during El Niño episodes throughout history, with data going back to 1950. And typically, during El Niño seasons, deposit temperatures anomalies are generally suggesting below normal temperatures across the southern tier of states across the southern United States. Areas from southern California east across the Gulf Coast states to the Carolinas and Florida. Whereas precipitation, again, looking at above normal precipitation generally from California east across the southern Gulf Coast states and much of the East Coast. So this certainly bodes well to receiving better probability for above normal rainfall and cooler temperatures for our region. Whereas La Niña, again, is defined by cooler sea surface temperatures in the Pacific, whereas the 3-month running mean sea surface temperatures are half a degree Celsius below normal. Again, La Niña, just like El Niño, is measured in the same area of the Equatorial Pacific as El Niño is, in the Niño 3.4 region. And in order to have a distinct La Niña episode, sea surface temperature conditions must be met for a period of at least 5 consecutive months. So the same criteria is the same with La Niña as with El Niño. We're looking in the same areas of the Equatorial Pacific. We're looking at the same time frame in order to have La Niña episodes to be met. The difference is La Niña, we're trending towards below normal sea surface temperatures. So looking at the effects of temperature and precipitation across the continental United States does not bode well across much of the southern plains and lower Mississippi Valley region in terms of temperature and precipitation. Anomalies here based on La Niña episodes throughout recorded history have suggested that temperatures are above normal in these areas, and precipitation is much below normal, really, from areas of southern California east across the southern plains, lower Mississippi Valley, and the east towards the Carolinas. So, as you recall, we did have back-to-back La Niñas during 2010 and 2011. And that the La Niña, the strong La Niña that we had in 2010, only had a drought situation, as we well remember, back in 2011. Certainly a historical hot and very dry year that year, as well as some of the worst drought resistant areas that we've seen. Certainly the business fire weather season that this office has ever seen as well. Through the typical jet stream patterns associated with El Niño and La Niña events. Typically with El Niño, you have low pressure that develops over the eastern Pacific, allowing the subtropical jet to remain fairly active across the southern United States. That results as La Nina episodes, we have a blocking ridge of high pressure across the eastern Pacific and just south of Alaska. So that tends to deflect the cooler and wetter conditions further to our north and east, leaving much of the southern United States very dry and very warm. Looking at recent sea surface temperature indices here, really going back the last several years, back into the late 2009. This was our last El Nino event back here in late 2009 and early parts of 2010, a fairly strong El Nino episode that had developed there. You can actually see the two La Nina episodes that developed during 2010. It's characterized here with the below normal sea surface temperature anomalies. We did kind of mellow out during the late winter and spring months of 2011, but again, we fell back below into La Nina, another La Nina episode, not quite as strong, but it only aggravated the drought during the summer of 2011. We did begin to recover, and as you can see here, back late summer and early fall, the Climate Prediction Center had forecasted an El Nino episode to develop late that year and into 2013. However, as I come to remember, they issued the outlook, and then sea surface temperatures really began to cool after that, and so really that forecast really popped out, unfortunately, for the most part. But we've been essentially in neutral conditions really ever since late 2012 here. And as you can see here, closing in here the first few months of 2014, latest weekly value is minus 0.205. Still pretty much right at about normal for this time of year, though. We did see some warming of sea surface temperatures here by about 0.2 Celsius here just in the last week or so. And that's contributed to a lot of warmer water within about the lowest 100 to 200 meters below the surface out in the Equatorial Pacific. It's beginning to mix towards the surface, contributing to the warming of these sea surface temperatures in this particular region. Now, these were the latest sea surface temperatures taken as of March the 12th, again taken from the Climate Prediction Center. Sea surface temperature anomalies are indicating near normal or slightly cooler than normal waters, but again, this blue area that you see here, it is quickly eroding some of that warmer water the lowest couple hundred meters down below the surface of the sea here, beginning to upwell towards the surface here. So expect possibly here in the next few weeks or so for sea surface temperatures to continue to climb in this particular region, the Niño 3.4 region. So looking ahead, how strong will the ENSO conditions be later this spring? Well, a lot of our dynamical and statistical models are suggesting for El Nino conditions to develop, especially sometime by mid to late summer, and perhaps continuing through the remainder of the year. As we recall, again, El Nino is certainly good for our area, which gets us cooler than normal temperatures and above normal precipitation. None of the models, at least, and this was initialized back in mid-February, we're not painting a particularly strong El Nino event at this time, though. I do want to emphasize that this is a very low confidence forecast, and I'll tell you why. The probabilistic ENSO forecast here, again, is trending towards El Nino conditions, as I stated, towards the mid and especially late summer months and during the fall and winter. But again, probabilities are just over 50% at best. Still above normal for the climatological probabilities that you see here later on in the year here. So why do we have such low probabilities here for this particular ENSO forecast?